Welcome to the second video in Unit 7. This is graphing logarithms and converting them, log to exponent, exponent to log, and evaluating a few simple logarithmic expressions. To graph a logarithmic function, you typically start with its inverse, which is the exponential. So we're starting here with f of x equals 2 to the x, and we're going to write some points down, graph it, and then graph the inverse, which will be the log of base. Let me write it out here. This is the inverse, log to the base 2 of x. So I have x and y. So -2, -1, 0, 1, and 2. So 2 to the -2 power is 1/4. 2 to the -1 is 1/2. 2 to the 0 is always 1. Then 2 to the first and 2 squared. So we're going to graph this. 0, 1, over 1, up 2. And then I have the asymptote down here. Okay. All right, so remember that to graph the inverse is the reflection over the line y equals x. So I'm going to draw that line just to remind us that this is y equals x. And then to graph the inverse, I'm just going to switch it backwards. So where this said -2 1/4, I'm going to go over 1/4 and down -2. On the next one, I'm going to go over 1/2 and down -1. I'm going to do 1, 0 instead of 0, 1. I'm going to do 2, 1. And I'm going to do 2, 3, 4, 2. And draw in the same. All right, so do you see then that in the exponential, I had an asymptote at y equals 0, but in a logarithm, I'm going to have an asymptote at x equals 0. So remember that you form the inverse by switching x and y. That shows a reflection of y equal, over the line y equals x. So the black function is y equals log to the base 2 of x, and the blue function is y equals 2 to the x power. And that's how that works. So here's a recap of what we just did. Determine the base, use the calculator to graph y equals 3 to the x, or you can just find those points by hand, just like we did. Reverse the x and y coordinates to find the inverse, and then graph the inverse. So you can see here that log to the base b of x is a continuous one-to-one function. Its domain is all reals, all positive reals, so x is greater than 0, and its range is all real numbers. Its asymptote is the y-axis, and it does have an intercept. It's at 1, 0. And you can kind of see what they look like if, depending on what the base is. Like if it's growth or decay, this is a growth, this is a decay. So if you wanted to find which one of these is the function log to the base 5 of x, you would remember that its inverse is y equals 5 to the x power, which would have two basic points, right? If it's 0, it would be 1, and if it's 1, it would be 5. So what I'm looking for on the log base 5 of x would be the points 1, 0 and 5, 1. So I look here, over 1, 0, no, so it's not this. Over 1, 0, yes. Over 5, 1, no. Not quite. So B is close, but not quite. This one, C, is not even close. This one here, over 5, up 1, the answer is D. So now remember, I didn't plot that many points. And as long as you can just plot a couple of points, notice that these two are going to be your main points, then when you switch the order, it's easy to find. So typically I put problems that I want you to try at the end of the video. This time I put 2 problems in the middle of the video. So I would like for you to graph the function log to the base 3 of x, graphing 3 to the x first, and then graphing log to the base 3 of x. Then below, the second problem I would like for you to do is to list the base and transformations of this function. Right? I'd like you to do this before moving on in the video. So logarithmic functions are also parent functions, and so they can be transformed in the same way. Horizontally, so you look, if you look on here, this would be the stretch or shrink. If it's negative, it would be a reflection. This is to the right or left, and this one is up or down, just like what you said. Okay, so over here, you can see here that this has a vertical shrink by a factor of 1/3. And then this, since this is not in parentheses, this would just be down 1, not right. It would actually have parentheses like this if it were right. Actually, the parentheses would be like that. Sorry, not around the log, just around this part right here. That would be right. But as it's written without the parentheses, that would be down. Okay, so the base of this logarithm would be 1/3, right? The parent function would be log to the base 1/3 of x. That's the parent function. The minus would be a reflection over the x-axis. The 4 is a vertical stretch by a factor of 4. This plus 2 is going to the left 2 units. And then finally, minus 5, it would be down 5 units. Okay, so logarithms have bases, just like exponentials do. It's written just a little bit differently. We remember that logs are the inverses of exponential functions. And also something that's very important to remember is that a log is equal to an exponent. The log is equal to an exponent. And that's worthy of writing down. Because when you get lost in all the converting back and forth, if you can just remember that a log is equal to the exponent, the rest of it kind of comes out to be the same. So for instance, if you have y equals b to the x, then the log could be written like this. Log to the base b of y equals the exponent x. And that's what it means. So down here, if you're going to write log to the base 10 of 1 over 100 equals -2, if you're going to rewrite that as an exponential, you would say that the base, right, 10, to the exponent, -2, is going to equal 1 over 100. So that would convert it from log to exponential. Okay, if I do the same thing here, base to an exponent equals a value. So 3 to the second power is equal to 9. And however you rewrite it, especially if it's all filled out numerically like this, it's true, right? 10 to the -2 is 1 over 100. 3 to the second power is 9. So it will be true when you write it that way. Okay, so here are some exponentially written, and they want you to write it in logarithmic form. So you would say log to the base 5 of 125 is equal to the exponent, which is 3. So sometimes I do this backwards circle, and I don't know, that helps students sometimes to see. Start with the base, go to the value, and it's going to, remember that a log is equal to an exponent. That will help you. All right, so on here we have the base. So log to the base 27 of 3 is equal to the exponent, which is 1/3. And that's how that works. Okay, if we were going to write this exponential as a logarithm, we would say log to the base 10 of 35 is equal to x. And now this log to the base 10 is something that we call the common log, log to the base 10. In fact, it's so common that if you just see a log without any base written at all, you can assume that it's the common log. And this is the same log that is the log key on your calculator. It's built into a calculator to do log base 10 and then log base E, which is called ln, the natural log. And we'll talk about this one a little later. But what you would do is you would actually just go to your calculator and you would hit log, log, and then 35. And you'd notice on your calculator it would not have the 10 as the base. And when you do that, you're going to get 1.5440680044. And I'm not rounding at all. That's exactly what it gives you. And so you can use your calculator because it is a common log. Okay, so you can evaluate logs without using your calculator. I'm going to show you a way later to use your calculator, but here's a way that you can write it without using your calculator. I'm going to rewrite it as an exponential and solve. So I'm going to set my log, this log base 3 of 243, equal to x, and I'm going to write it as an exponential. So I would say 3 to the x power is 243. Now, remembering from an earlier video that 243, when you factor it all out, is actually equal to 3 to the 5th power. So 3 to the x is equal to 3 to the 5th. The one-to-one property says that if the bases are the same, then the exponents are the same. So log to the base 3 of 243 is going to equal 5. All right, we can do the same thing with this one down here. We would say 10 to what power is equal to 1,000. And we remember that 1,000 is just 10 to the 3rd power, one-to-one property, so x equals 3. And that's how that goes. So be sure that you did the graphing problem and the transformation problem found earlier in the video. Have that in your composition notebook ready to go. And then we are going to evaluate logarithmic equations and expressions later on in class. So we'll see you then.